actually stopped to think about the plastic containers sitting in your kitchen or the smooth asphalt roads you drive on every single day? What about the life-saving medicines in your bathroom cabinet? Well, what if I told you they all share a totally bizarre ancient origin story? It is absolutely mind-blowing, but they literally started out as microscopic sea creatures and lush swamp forests hundreds of millions of years ago. Welcome to today's Explainer, where we're going to trace that incredible journey, going from ancient biology straight through to modern energy. Okay, let's dive into our roadmap for this Explainer. First, we'll look at our natural resource bank, and then see exactly how these fuels were forged in the deep past. From there, we'll unearth coal's hidden uses, refine modern black gold, explore the natural gas alternative, and finally confront the consequences in conservation. Section 1. Our natural resource bank. So to really appreciate the journey of fossil fuels, we first need to understand that nature essentially hands us two totally distinct bank accounts. On one side, we have our inexhaustible natural resources. These are practically limitless in nature, and human activities just can't use them up. We're talking sunlight, wind, water. But on the flip side, we have our exhaustible natural resources. These are present in a strictly limited quantity. Things like forests, minerals, and, critically for our explainer today, coal, petroleum, and natural gas. Because they're limited, human activity can and will eventually use them up completely. And honestly, this immediate contrast sets some extremely high stakes for our energy consumption today. Section 2. Forged in the deep past. Let's travel way, way back in time. The fuels we rely on today, we call them fossil fuels because they are literally formed from the decomposed remains of ancient life. Just think about this massive gap in time for a second. You have a lush prehistoric forest from 300 million years ago, slowly transforming into a hard, black lump of modern coal. Now, coal might just look like an ordinary stone, but it's actually a highly complex chemical mixture. It's packed with carbon, hydrogen, and oxygen, along with little bits of nitrogen, sulfur, and phosphorus. To get from a living green forest to this dense black rock, well, it takes a spectacular series of events. It essentially starts with natural disasters. Floods, earthquakes, and massive volcanic eruptions buried these ancient plants and trees deep beneath the surface of the earth. Over time, they got completely covered with massive, heavy layers of sand, water, and clay. Down there, under extremely humid and hot conditions, anaerobic bacteria went to work. These bacteria slowly, methodically attacked the organic matter. They stripped away the oxygen and hydrogen, leaving pretty much just the carbon behind. And this incredibly slow chemical process, happening under intense pressure and temperature and the total absence of air, that's what we call carbonization. Now let's see how this builds up over time, because carbonization doesn't just happen overnight. It happens in these very distinct stages, with the carbon content bumping up at every single step. It starts out as buried wood, turns into peat, and then, under even more burial pressure, heat, and time, it becomes lignite. That's a soft coal with about 25 to 30% carbon. Keep applying that pressure and it transforms into subbituminous and then bituminous coal, which is your medium hard coal. Finally, at the very end of this agonizingly slow process, you get anthracite. This is a hard coal boasting a massive 86 to 97% carbon content. But hey, what about the oceans, right? While those forests were turning into coal on land, a totally different microstory was happening deep underwater. Billions of microscopic animals and plants living in the sea died, and their bodies just settled at the bottom of the ocean floor. Slowly, they were covered by layers of clay and sand. And just like with the coal, immense temperature, high pressure, and bacteria acted on these organisms in the complete absence of air. But instead of coal, they were converted into petroleum and natural gas. These precious fuels then slowly seeped upward through the earth until they became trapped between two massive layers of impervious rock, forming what's basically a natural oil trap deep underground. Section 3. Unearthing coal's hidden uses. Let's fast forward to the industrial age. We've dug up this buried fuel from major mines in places like Bokaro and Ranaganj. But you know what? We do so much more than just burn it. We tend to think of coal as just chunks of rock, but look at this surprising web of everyday products. By processing coal, we extract starting materials for all sorts of organic compounds. This means derivatives from coal actually end up in our synthetic fibers, our plastics, fertilizers, explosives, dyes, and incredibly, even the medicines we take. It's basically everyday magic. The chemistry of ancient swamp life is sitting right there inside your medicine cabinet. To be specific, when we process coal in the industry, by heating it up without any air, we get three main byproducts. First up is coke. It's tough, it's porous, and it's black. And because it's almost pure carbon at 98%, it's absolutely essential for manufacturing steel and extracting metals. Second is coal tar. Now, this is a thick, honestly foul-smelling liquid, but it's actually a mixture of around 200 carbon-containing compounds. It's the vital raw material for those paints, drugs, plastics, and explosives we just talked about. And finally, we have coal gas, which we get during the processing of coke, and that's heavily used as a fuel in various industries. Section 4. Refining modern black gold. Okay, moving over to liquid fuel, we have petroleum. The word actually comes from the Latin petra, meaning rock, and oleum, meaning oil. It's quite literally black gold. But here's the thing. Crude oil straight out of the earth is a completely messy mixture. To make it usable, we have to separate it through a process called fractional distillation. Notice how this works strictly based on boiling points. Down at the scorching bottom, at 340 degrees Celsius, we get heavy molecules like bitumen. Then, as temperatures drop, higher up the column, the lighter molecules separate out. At 270 degrees, we get diesel. At 170 degrees, kerosene. All the way up to the very top, at a cool 20 degrees Celsius, we capture the smallest, lightest molecules of all, refinery gas. So the truly crucial point here is how each of these specific fractions maps directly onto our daily lives. That heavy bitumen from the bottom of the column, we use that for surfacing our roads and roofing. Paraffin wax, that goes straight into your Vaseline, shoe polishes, ointments, and candles. Kerosene fuels our stoves and aviation. Gasoline, or petrol, fuels the cars we drive. And liquefied petroleum gas, or LPG, provides gaseous fuel for our homes and industries. But it goes way beyond just burning these fractions for energy. Petroleum gives us petrochemicals. These are the raw materials for a huge variety of substances. Much like coal tar in the past, petrochemicals have largely replaced earlier materials. They are the chemical building blocks for synthetic rubber for our tires, synthetic fibers for our clothing, and, get this, even the perfumes we wear. Yes, your expensive fragrance technically started its life as ancient black sludge. Our modern world is quite literally synthesized from this black gold. Section 5. The natural gas alternative. Remember those natural oil traps under the earth we talked about earlier? Well, right above that heavy petroleum, we often find natural gas, which is primarily made of methane. And natural gas has some incredible advantages. It has a super high calorific value and burns with a smokeless flame, which means it causes significantly less air pollution. It's just a much cleaner fuel overall. Plus, it doesn't produce poisonous gases when burned. Because of all this, compressed natural gas, or CNG, is increasingly being used in transport vehicles. What's even better is that it can be efficiently transported directly through underground networks of pipes, no extra storage needed. In India, for example, natural gas is supplied exactly this way in Vadodara city and parts of Delhi. It's also completely vital in the fertilizer industry as a main source of hydrogen gas. Section 6. Consequences and conservation. Now, we just learned that these fuels took hundreds of millions of years to form, right? Yet our modern consumption of them is just staggering. Let's take an objective look at the stark data regarding this over-extraction. Because coal and petroleum are exhaustible, the rate at which we are currently burning through them means the available stock may last for only about the next 20 to 30 years. That is an incredibly tight timeline. Economically speaking, as stocks deplete, importing costs are going to skyrocket, leading to severe inflation. Environmentally, excessive mining creates hollow spaces in the earth, risking literal land collapse. But perhaps most visibly, burning these fuels releases massive amounts of carbon dioxide, leading straight to the greenhouse effect and global warming. It also releases oxides of sulfur and nitrogen, which mix with rain to create acid rain that actively damages buildings and soil. On top of all that, the unburnt soot particles released are known to trigger asthma and severe respiratory disorders in humans. So what can we actually do practically right now? Well, in India, the Petrol Conservation Research Association, or PCRA, offers some really immediate, actionable tips to save diesel and petrol. First, regularly check the air pressure in your tires. Having the correct pressure drastically improves fuel efficiency. Second, maintain a constant and moderate speed, ideally between 45 to 50 kilometers per hour, because very low or very high speeds just chew through fuel. Third, simply switch off your vehicle's engine at traffic signals or whenever you're waiting. And fourth, ensure you're getting regular vehicle maintenance from authorized companies for better, more efficient repairs. These personal habits, like maintaining a steady driving speed, are absolutely vital. We have to restrict our usage of these fuels to when it is completely necessary and never, ever waste them. But honestly, conservation alone isn't going to be enough. we have to actively shift our reliance. We must adopt and transition to alternative, inexhaustible sources of renewable energy. We're talking about solar, wind, nuclear, tidal, and biomass energy. Even simple changes like using biogas as a domestic fuel instead of relying on fossil fuels can make a massive difference. Which brings us to the ultimate question we really have to face today. We've seen this incredible 300 million year journey from ancient prehistoric forests right to the fuel sitting in our tanks. But with the data clearly showing that our fossil fuel stocks could completely run out in just the next 20 to 30 years, are we truly ready to transition to the inexhaustible alternatives? Thank you so much for joining me on this explainer. I hope this leaves you with a whole lot to think about, and I will catch you in the next one.